joint variation may involve more than two variables. It occurs when one quantity varies directly as the product of two or more other quantities. Okay, let us write this in mathematical sentence. In a given statement, y varies jointly as x and w. So we write y, this is a product, remember? So we'll have k as our constant of variation and the product of the two other variables that are involved. So that's x and w in this case. Remember, variables may change except for the constant of variation. Now, from here, how are we going to solve for the constant of variation? We will simply derive this. How? We write it as y is equal to kxw. Now, we want to find the value of k, so we need to eliminate or remove the other variable beside k. So, to do that, we multiply both sides with x with 1 over x and w. 1 over x w. So that we multiply kxw times 1 over xw, will have this xw is equal to 1. Then we'll have in the numerator 1 times k is equal to k, and on the left side we'll have y over x and w. This is just the same if we will rewrite it as k is equal to y over xw. This is now the formula that we can use in finding the value of the constant of variation. Remember, we will simply derive the original joint variation equation that we have. To translate the following statement into mathematical sentence, we have A varies jointly as B and C. Again, we have to write A in the left-hand side of the equation is equal to K because of the varies jointly is like a direct variation. Then we add the variables B and C. Same step we'll use to write the given in number 2. And for number 3, still the same, only that it will have more than two variables to multiply, L, W, and H. For the first problem, the variable x is in joint variation with y and z when the values of y and z are 4 and 6 and x is 16. What is the value of x when y is 8 and z is 12? First, we need to write a mathematical sentence from that statement. So we have x varies jointly. We multiply, get the product of the variables y and z. And then, we take note the values for each variable. We have the value of x, 16, the value of y, 4, and the value of z is equal to 6. And then we proceed on finding the value of our constant by deriving our equation. So we'll have to find k, we'll have x over y z. And then let us solve by substituting these values to our equation. K is equal to 16, the value of x, over the value of y is 4, times the value of z is 6. Then we simplify. (16 over 24). And then simplify again what is the GCF for 16 and 24? The answer is 8. Then we divide both by 8. So 16 divided by 8. Okay, that would be 2. 24 divided by 8 is equal to 3. Now we have our constant of variation. After finding this constant of variation, we can rewrite our equation and change the constant of variation like x is equal to k becomes 2 over 3 and then variables y and z beside it. Now we have the value, now we have our equation for this given problem. Let's now proceed on solving for what is asked, which is finding the value of x when y is equal to 8 and z is equal to 12. Simply substitute these values to our equation. Find the value of x is equal to 2/3 times the value of y, 8, and the value of 12. Z is equal to 12. Then we simplify. So 2/3 times 8 times 12. So that would be a big number. Instead of doing that, let's use cancellation. Which of these 8 and 12 is divisible by 3? So we can say that it's 12. So we cancel or we divide 12 by 3. The answer is 4. Now we have 2 times 8 times 4, which is left. So that would be equal to 2 times 8 times 4 is 64. This is now the value of x for our given problem. For our next problem, we have the volume of a tree trunk varies directly as the height and the square of the girth. The volume of a tree trunk is 120 cubic meters when the height is 10 meters and the girth is 2 meters. So that is our given. The question is, what is the height of a tree with a volume of 486 meters or cubic meters and girth of 3 meters? We have. So the volume varies directly. This will be the product of h and g squared because it says the squared of girth. Then we have to find the formula in finding the k or the constant of variation. So we simply derive the equation. So we'll have k is equal to v over hg squared. Now we have this formula for k and this one for our mathematical statement. Let's identify the values for each variable. We have v is equal to 120 cubic meters. Next, we have the height is equal to 10 meters and the girth, which is 2 meters. Let's solve for the value of our constant of variation by simply substituting the numerical coefficient of each variable. K is equal to v 120 divided by the value of h 10 and the value of g, which is 2 squared. So we have k is equal to 120. Simplify the denominator. What is 10 times 2 squared? That would be 4. 10 times 4 is 40. So we'll have k is equal to 120 over 40. And then we simplify this. 120 divided by 40 is 3. The value of our constant of variation is 3. Then we go to our equation and change k with 3. That's v is equal to k is 3. Then copy the variables h and g squared. This is now our equation for the problem that we are about to answer, which is what is the height of the tree when the volume is 486 cubic meters and the girth is equal to 3 meters. Simply substitute. V is 486 is equal to 3. And then hg squared. What is our h? That's missing. And then g, 3 squared. What is 3 squared? So that is 9. So 3h, 9. Let us combine 3 and 9. What is the product of 3 and 9? The answer is 27h. And then 486 on the left side. Simplify by multiplying both sides with 1 over 27. Now we'll have h is equal to 486 divided by 27 equals 18. What is the height? Let's put the correct unit of measurement with our answer. So we'll have 18 meters. Height of the tree when its volume is 486 cubic meters and the girth is 3 meters. For a given interest rate, simple interest varies jointly as principal and time. If 2,000 left in an account for 4 years earns interest of 320 pesos, how much interest would be earned if you deposit 5,000 for 7 years? So let's have first the mathematical equation for that. So we have the interest is equal to the varies jointly with principal and time. To be able to solve for k, we derive this equation. So now we have k is equal to interest over p over time. Okay. Next, we take the values for each variable. We have I is equal to interest is equal to 320 pesos. The principal amount is 2,000 pesos. Don't forget pesos. For our time, we have 4 years. This is the initial given. From there, we solve for the value of our constant of variation. We have k is equal to 320 over 2,000 times 4 years time. And then simplify. So we have k is equal to 320 over 8,000. And then simplify more. So let's have k is equal to 32 over 800. Simplify 32 over 800. We have k is equal to 1 over 25. After finding the value of k, we change our equation with the numerical coefficient, numerical value for k, which is 1 over 25. Now, our equation is I equals 1 over 25 pt. Now, we are ready to answer our problem. How much interest would be earned if you deposit 5,000 pesos for 7 years? So, our principal this time is 5,000 pesos. Our time given is 7 years. 7 years. Okay, let us now solve for the interest. I equals 1 over 25 times 5,000 times 7. So, we simplify this. 5,000 times 7 is 35. Sorry. Copy first. 1 over 25 times 35,000. And what is 1 over 25 of 35,000? The answer is 1,400. So, our interest is equal to 1,400. Now, we have the unit of measurement, 1,400 pesos. Let us analyze. In the first scenario, we started with 2,000 pesos for 4 years. The interest is 320. Now, we increase the amount, principal amount, with 5,000 pesos, and we also increase the number of years. Obviously, it follows that the interest will also be greater. So, for 7 years of 5,000 pesos, the interest will be 1,400 pesos.